very happy to be here. Happy that you came to choose me to my session. I'm going to talk to you about actually not a story. So this is not like one of those success stories where we actually have this in production. This is more of an idea that we have about adopting this tool for a use which is not actually the real use that it was designed for. And we are thinking about using it as operational runbooks. So I chose to use the term runbook because if I said playbook, people would think this is Ansible stuff. It has nothing to do with Ansible, so I went with the term which does not have any possible conflictual meaning. And well, operational runbooks are basically operator instructions. So it's kind of stuff that you go to when there's an outage to resolve, and you have like some written down instruction with how to fix the issue, hopefully. So this is an idea, and this means that I'd like very much to hear your thoughts, ideas, criticism on this proposal I'm going to make. And as I like to say to people who work in my team, remember there are no stupid questions. There can only be stupid answers. So I'd like to invite you to ask away. You can ask at the end of the session if you have something very urgent, even while I'm talking. Otherwise, you can catch me later. I am the DevOps team lead at Premium. We're a global company based in Germany, and we provide CAN bus solutions. Solutions for CAN bus applications. So the CAN bus is basically the Ethernet network-based kind of inside your car, very simplified. And with all that, let's just jump into the presentation. But well, first, show hands. Who knows Jupyter notebooks? Is aware what they do? Okay, nice. So how did we? Oh, I have to use. It's very embarrassing. Okay. How did we get to Jupyter notebooks in a DevOps context? Well, starting last year, we began to perform staged incidents. So we took postmortems and we enacted the postmortem in a controlled fashion in our stage environment, and we used those, to like an exercise in troubleshooting a running system. We use those for a couple of reasons. Well, training new people, so onboarding people to on-call, also training new team members so they learn how the system works. The best way to learn about it is to poke the system and see how it interacts. And it's also useful for us, of course. The other reason is it's kind of an exercise and see how much you can teach troubleshooting to people. Usually troubleshooting is kind of a black art. People guess from their gut what is going on and then they fix it. We try to see if that's actually something that can be taught. So we started enacting these stages, and so what would happen is that usually when we enact a stage instant, an end-to-end check, like black box monitoring test, will fail, and usually for those we have operator instructions, which is a link to some markdown document in one of our GitHub repositories, which instruction how to fix and resolve the problem. What was the problem that we saw? The problem was that these runbooks are actually narrative, so it's text. It's basically plain text that you read, and they might have links to dashboards or tools for actions to perform, but it's still text. So one obvious problem with that is that they can fall out of date. So you change your architecture and suddenly your runbook is outdated, or it's hard to find where the runbook is detailed enough that it's clear for the person reading it where to act, but it's not detailed too much so that if you change even something slightly, then it will be outdated. So what happened was, like in the summer last year, we started hearing about Jupyter Notebook, and there was actually a post from a guy about using Jupyter notebooks in the DevOps context. It didn't get very far, I think, because it was only one post. But that kind of gave us an idea, and maybe we might be onto something here. So we started looking into them, and since then we also have started a data science team, which means they already use notebooks. So the concept is that if this does not work for us as the DevOps team, as a solution, it will still be useful as a solution for the data science team, so it will not go to waste. So we started working on this we have a free time project allowance, so we started working on this, on that free time. So what are Jupyter notebooks? I like very much this definition from Matthew Seal at Netflix, an engineer at Netflix. Netflix, by the way, has been investing a lot in Jupyter notebooks, and they have a bunch of posts and interviewing podcasts about Jupyter notebooks. So if you're interested, you should really check this out. And I really like this definition because it captures kind of the essence of what the Jupyter notebook is, because it's really a multifaceted thing. So let's kind of break down, like deconstruct this the description. So it's a document which, you know, it kind of gives you the idea that this is not like some source code. So it's not just plain source code. It's also a document. So it kind of gives you the idea. It can contain formatting and media and other stuff. It can contain live code. So there's actually text areas where you can have code and actually run the code from the document. That code can generate visualizations, can generate documentation, so that code can actually interact with the document itself. And it can also have many other types of components, and like you can have UI components like buttons, sliders that you can drag, and dragging will actually alter the document itself. And then the last thing that I like a lot is it is kind of a shareable IDE, which means that it is something that you run in the browser. So you have a link to the notebook, you load it in your browser. There are no dependencies that you have to run locally. It's like who saw the presentation from Massimo about AWS CI/CD pipeline? If you saw, he used Code9, which is an IDE editor in the browser. It's a product that they acquired from a Dutch company, and that's pretty much like that. So there's everything in your browser. So if you have like a notebook which loads pandas, Python, the libraries, you don't have to install those kind of things on your computer. You just open it in the browser and run it. It will run in the server and get results back to you. Which means that you can create a notebook and share it with the rest of your team quite easily once you have a link to the file itself. So I'm actually going to show you an example of a notebook, just to kind of give you a little example of what a notebook is. You can see here that it runs in the browser, so that's pretty simple. There are actually a couple of interfaces for running notebooks. I'm going to show the Jupyter Hub one, which is kind of I think the most popular one. So let me switch here. So this is the Jupyter Hub instance. It's running on my laptop actually. This is the example that I want to show you first. So this is not a runbook. This is just to show you the kind of powerful presentation you can achieve in a notebook. So here what we're going to do, we're going to query our REST API and fetch some information presented in a couple of different ways. You can see that it's a document because there's actually a table of contents. So it pretty much looks like a document that you would expect. And the building block of a notebook is the cell. So this area here that you can see like surrounded by like a table is a cell, and each cell can be run independently from the others. And you can run a cell just by clicking the run button here. And when you run the cell, the code in the cell will run and the results will be presented back to you. And they will be sent back to you as they run. So if there's a loop, you will actually see the result of each execution of the loop and not just the loop all at once in the end. So we run each code, each cell. So by clicking run, it will actually shift to the next cell. So we just loaded some libraries. This is some markdown cell. So just for simplicity, let's just say that we can have two kinds of cells, code cells and markdown cells. In this case, code is Python, but there are actually implementations for pretty much any language that's out there. So Groovy, Java, R, whatever. So you run a markdown cell, we just render the cell. Now we move down. This is a widget, so this is actually a text field. So you can see that it can actually render text fields. I'm just using the very simple ones just to give an idea. Okay, here we are creating the API. Here we are showing just some very simple text output, so very simple. Now we're going for a map, which is more interesting, I suppose. Just waiting for the REST API to respond. Right, so you can see there's a map here. It's actually a map that you can zoom in, zoom out. It's like the real thing. Then you click again. Now we start exploring time series data. So here we query from all the metrics that this vehicle has, and they are shown in a table like this. And now we query more data. And now we want to plot one of these metrics. This is the sim traffic allowance per month, and you can see it as a nice sawtooth pattern, which is appropriated for something that's on a monthly basis. So this is the kind of powerful experience that you have in a notebook. The idea is that we want to change the experience of someone who's loading, maybe in a stressful situation, an operation runbook, and then the operation runbook says, check that this thing is running correctly, and check this device is sending data, and maybe make sure that this data is in this table. And you would have to do those checks manually, but if you have a notebook, you can actually have the notebook run the checks for yourself. So that's a very powerful, we think, construct which simplifies going through the instructions in a runbook. So before we jump into an example of a runbook, I want to describe a little bit how we decided to deploy. I think the most popular way to deploy Jupyter Hub is using Kubernetes. I think there's an Helm, how it's called, task recipe for deploying on Kubernetes. But we don't run Kubernetes, so we decided to go for something simpler. So we just took the basic Docker image, customized a little bit, and we deployed the Docker image. So what happens is that it's a self-service. You just we leverage rundeck for most of our self-service operations in the data center. So people just go to rundeck. If they're authorized to run the job, they just run the job and then get back URL, login and credentials for their Jupyter Hub instance. So there's no human involved whatsoever in the process. If they break their own instance, they just run the rundeck job again, they get a new one, and that's it. We also decided to go for an ephemeral implementation. So each Jupyter Hub instance that you get will be destroyed by the end of the day. So you use it, and then at the end of the day it's destroyed. If you need it again the day after, you get a new one. This kind of enforces this kind of garbage collection, if you want. Like people usually need for a short computation time, then they get a new one in the day after. The reason for going ephemeral are mostly that we want to minimize operations regarding this tool. Since this tool is actually running code, so people are actually running code in this one. Maybe they want to install a new module. They want something which is very heavy. So the Jupyter Hub instance breaks. What they have to do, they don't have to call support. They don't have to do anything. They just start again their own instance. So there's no there's minimized interaction with support in case something goes wrong. And other benefits from being ephemeral is that we can roll out updates without worrying about disturbing running instances, because we just deploy a new version of the image, and then the day after, when people after we deploy the image, when people start their own instance, they will pick up the new image with the new software. So it's kind of painless. Finally, another interesting consequence is that we allow people to install packages in the instance. So if they need to try out a new library, they can do it without having go through the process of requesting a new version of the library. They can just go into the Jupyter Hub terminal, install the package, or do whatever they need to do, and then they try it. If it works, it's fine. They can file a pull request to update the image with a new version. Otherwise, they can just destroy the image and get a new one if they break it. Because there's some dependency problem or stuff like that. So those are actually the reasons for that we decided for going with ephemeral implementation. Wait, this one, skip it. The other reason is that we we kind of took inspiration from SageMaker when designing this kind of solution. And the other reason for going ephemeral was that whenever you launch your instance, we fetch a bunch of repositories, the one that you actually tell us to, into your image. So it's preloaded in your environment. So if you're a data scientist, you have maybe 2 or 3 repositories with your most popular notebooks, and those will be present in the latest version that's on the branch that you told us to fetch in the repository, which means that you will always have at least the version of your notebooks that's one day old. And that's pretty much, those are pretty much the reasons, but I have to say it's probably the reason is to minimize operations and impact on our team, so there's no need to intervene in case something goes wrong. So with that being said, I'm going to jump into a demo. So any questions about so far? Okay, cool. So this is, I have of course simplified a little bit the instruction because we don't have much time, and I also wanted to keep it like very focused so it was simple to follow through. What we do at Premium, we basically have devices that you install on tractors and trucks and harvesters, usually heavy machine equipment, and these devices will send data to us through mobile network, Wi-Fi or Bluetooth. What we do, we process that data, store it in Elasticsearch, and we use it as metrics time series DB. And then we give you the data back if you want through the API, or there's a data portal you can use for that kind of stuff. Now for some data, so that's the raw data that we received on the machine. For some data we also do some post-processing. So we migrate the data from the raw data to a migrated state. So maybe we do like accumulation, we derive counters from absolute values and stuff like that. So this runbook is actually about checking that this migration process is actually working. So what the runbook tells you to do is, so this is the end-to-end test machine, which is actually, so it's actually a physical device that we own and sends us data. It's actually sending us the data, so check that we are actually receiving the data, and then check that the data is actually migrated. So we should find a new value for the raw data and a new value for the migrated data in the last X minutes. So that's basically what the end-to-end test does. And the runbook tells you, to check that in case there's a failure of this end test, it tells you to check which one of these steps failed. So you can see that step 1 tells you check that the CU, the communication unit, the physical device, is sending us data. So one would actually go to Kibana and query Elasticsearch index for the most recent time range. If it is, then check that the batch migration job is run, which means check that the migration data is actually there in Elasticsearch. If it's still not sending us data, then you can try rebooting the device. It might happen sometimes that the mobile network operator has hiccups, so you have to reboot the device so it picks up the mobile network again. So what happens is that the operator who's on call would actually have to go to Kibana, query Elasticsearch, know what index it is, know also what the raw signal is, which is not simple because this machine is like probably 50 signals that we are receiving. So you'd have to know which one is the raw signal, which one is the migrated signal, and then find them in Elasticsearch and find the results. All this usually in a stressful situation because the system is impacted. So it's not really like you're calm and quiet. It's 3 o'clock in the afternoon. Maybe it's night. I just woke up. So so those instructions. Well, they could become Python code where you actually access Elasticsearch, query Elasticsearch, and then the runbook will actually tell you if the data is there, if it's up to date. Okay, there's no guessing game involved in which the operator has. Oh wait, what's the new version of the raw data? There's no guessing involved whatsoever because that information is actually encoded in the notebook. And the cool thing about the notebooks is actually you can also schedule them. So it might break, but it will always run because if you schedule it regularly, then you will know that it still works and it queries the right data. So what would the operator do? Well, it would just select the first cell and then start running the cells in order. That's it. So you see here we are querying Elasticsearch from the vehicle and using a time range. We cap the results to 100. To the last 100. Now we import the time series data and do a little bit of processing, and now we establish if we are receiving the raw signal. So you can see here that the notebook tells you that the raw data age is 23 seconds. It is therefore okay. So the communication unit is sending us data and we are processing to Elasticsearch. So now we know that the first step of the job is actually working. So the communication unit is sending us data and we process it. And we processed it 23 seconds ago. Now let's check the second step, which is the migration of the data. So now we check the migrated data signal, and now we compute the age here, we compare it, we check it's not more than 10 minutes. If it's more than 10 minutes, we raise a warning, and we can see here, now running the code, okay, the migrated data age is 65 seconds, so roughly 1 minute, which means the migrated data status is still okay, and it will tell us that if we run it again. Okay, so looks like we're good. As we should be, because there's no end-to-end failure right now. Now, just as a precaution, we also check that the vehicle is online. So we create the API and it tells us the vehicle status is online. So you can see how a troubleshooting operation, in our opinion, becomes much more streamlined, right? There's no guessing, there's no thinking about how to use Kibana. There's very much less work to do here, and also the very cool thing is that suppose that the first step fails, like we can't find the raw data. What you can easily do, you can tweak the notebook right here. So say that okay, maybe 100 results is not enough. Let's try 200, right? So let's try it again. We patiently click. And now it tells us it found 200 results, right? So run it to the owner. It's still okay. It's still okay. Everything still looks good. So this is not only simple to follow through. You can actually tweak it on the fly if you're in doubt. You know, maybe there's a bug here. Maybe the notebook code is not correct. So you can actually tweak it on the fly, run it on the fly, and inspect the code as it's running. Another very cool feature of notebooks, I didn't show it before, I'm going to do it now, is that you can keep running a cell. So you don't have to run the cells in order like I did. It's usually best practice to do, but you don't have to. So if I run the cell until here, now I can keep running this cell as many times as you want, which means that I can keep checking the results as they are coming in. Okay. And now the other cool thing is that you can actually run the notebook from the command line. So we go back here, we open a terminal. Okay, now we run Papermill, which is the tool written by Netflix for scheduling, which they use for scheduling notebook. So I run the demo notebook and I save the output in IPyMV. So this runs the notebook. Okie dokie. I go back to home here. I find the file. Okay, so this is the file that is the result of the execution. So I open this file. I have to tell the notebook that it's trusted. Otherwise, it will not show images and interaction in the notebook. It will basically not run JavaScript. And the cool thing is that this notebook has actually now captured the state of the execution. So what I have here is the data, the results of the execution of the notebook at the time that it was executed. So if I go down here, you see 200 results. And here it says it's 29 seconds. So this number is different from the one that we have here, hopefully. Otherwise, I can run it again. And you see, 39 seconds here because I run it afterwards. So I think another interesting case would be, you're on call, you're first level support, you run the notebook. What you can do, you can save the state of the notebook, send it to second level support because this is the stuff that I already checked. There's no need for you to check it again. This is the results of the check that I did. Okay, I think this is a kind of interesting implication. For this kind of use. And so well, what are kind of like further developments? So we started with this idea of using Jupyter notebooks for runbooks, but after that we thought, maybe there are other interesting use cases. And so one interesting use case that we thought was, what if instead of having a dedicated runbook for the end-to-end check, what if you wrote the end-to-end check in the notebook itself? So the instructions are actually the end-to-end check itself. So you run the end-to-end check as a notebook, you store the execution on S3, and then you throw it away like every last 3 months. You keep on the last 3 months. So when the end-to-end check breaks, you can just see the state of the end-to-end check when it failed, because you just load the last execution on the notebook, you can see where it broke, and you can resume the execution there, further debugging and tweaking the notebook from there. So I think that's also a powerful construct. The fact that it supports most programming languages makes it appealing for teams that are not Python users, Java users can work with those, groovy. And another interesting use case that we found is, I'm pretty sure it happens for a lot of you. Have you ever had like a need, so there's maybe a task that you run like, maybe, I don't know, once every 2 months, and it's a long, tedious task with like lots of manual operations. So for us, it's we use Jenkins and Boars to configure merging to pull requests for GitHub repositories. And so what we have to do when there's a new GitHub repository and they want that integration, we have to go and configure Jenkins job. Then we have to go into the GitHub repository, configure the webhook, add the bot group to the permissions of the GitHub repository. Is that worth putting into a script for running like maybe once every 2 months? Maybe not. Maybe the cost is too much. But if you do it from a notebook, it actually turns out to be pretty cheap. Because even if it breaks, because you run it not so often that you will know it will always work. Maybe the GitHub API has changed. What happens is that you can just skip the step that broke and continue with the rest of the notebook, and then just run manually the step that broke, or fix it right away, and then submit the changes as a pull request. What is the difference between doing that in a script? Is that in a script you can just select a block of the script and execute just that block of the script, right? You have to execute it all. There's no way, unless of course you comment all the code, but then you have to know which variables are in the scope and taking that into account. So we think that's also another interesting use case. Those scripts are, you would like to have them automated, but maybe it's not worth making the investment in writing a full script for that. Maybe a Jupyter can be a good fit for that kind of use. The questions so far? Following through, everybody? Right? I'm surprised. I didn't think I would make it clear enough, actually, or it makes sense. Okay, what are the downsides? Well, there are of course a few downsides. One downside is that Jupyter notebooks takes, like all code, but in particular Jupyter notebooks take a lot of discipline to write them in a well coded manner. Actually, in the Jupyter Hub instance we used to run, we also installed PEP8 formatting, so you can actually format each cell to be PEP8 compliant just by clicking a button. So that helps also prevent. There's also a linter, I think, which we enabled by default. So code quality of the notebook might be an issue because it's usually used for quick exploration, right? So you want to go quick. You don't really. You think about that later, maybe no code quality. In this case, you really want to have good code. So that's one issue. The other issue that might come up is that people might be surprised by the fact that you have to run the cell in order. So if you see the notebook, you click one cell in the middle of the notebook, then it breaks because you have, of course, to run the notebook cells in order. Sorry? Because you click Yeah, exactly. So those are, a couple of quirks around Jupyter notebooks that are, might hit us. But the way the adoption that we see in Netflix and other companies, and also the success that the notebooks are having, like at the global level, I think we are onto something here. And well, as I said, anyways, if it doesn't work out for us, the DevOps team, it will still be a success for the data science team. So there's no, it's not like a completely lose-lose. It will be like maybe win-lose, win-win for them. With that being said, I made it in 30 minutes. I planned to. I will take any questions very happily. Anything. One thing I'd like to add, we are hiring. There's actually a DevOps position in my team. So if you're interested, let me know. Thank you.